Hello, everyone. May I have your attention? I think we're going to go ahead and start with the afternoon session. If there are people by the door who are going to come and attend the session, we ask that you join us now so we can stay on time. Do we have all the speakers for this session here? Can you raise your hand if you're a speaker? Okay, so we got 2. Okay, at least we have the first 2 speakers, so we can go ahead and get started. And I did see the other speakers around, so I'm sure they're going to come in anytime soon. Okay, so hi, my name is Maha Kinawi. I'm an assistant professor of civil and environmental engineering at Oklahoma State University. My background is structural engineering. This is my first time here, so I'm very happy to be joining. Thank you for joining the session. The session is going to be 1 hour and 25 minutes. Each presentation has 20 minutes, so we have 4 presentations. And there's no time for questions at the end, so that should be the time for the presentation and questions as well. So I'll ask the speakers to be mindful of that. Try to have a few minutes at the end of your 20 minutes for questions from the audience. So we're going to go ahead and get started with our first speaker. Michael Molina, head librarian from the Oklahoma Transportation Library, University of Oklahoma, and he's going to be presenting on transportation research and connectivity.
All right, thank you so much. This is a great audience. I'm excited to present on our pooled fund, and many thanks to our organizing committee for providing the wonderful lunch. I think it was a stroke of genius to provide some pasta and carbs for the afternoon session so everyone can stay awake and look lively. So this has been a good conference so far. I think we've all enjoyed the presentations, and this session I'm going to be presenting on a pooled fund project that would have been closing out, but we got renewed. We just found out we're going to be renewed for an extra 2 years, so we're excited to keep going with this pooled fund. And I'm going to tell you a little bit about the history of this project, how it's evolved, and some of the things that we'll be developing for the next 2 years that ideally will have ramifications for your work, whether you're in academia, you're in the private sector, or in the public sector. I'd like to give a special thanks to Ron Kerb, formerly of ODOT, and also Gary Hook of ODOT for supporting this pooled fund. This wouldn't exist without their support, so many thanks to them. So, excellent. All right, this may be a little hard to see, so I'll try to summarize as quickly as I can. So this pooled fund project was developed around 2020, March of 2020, with the goal of helping bring together other state departments of transportation, their research libraries, and helping to disseminate the research that other state DOTs do. We have a series of objectives that we have developed over the years, namely helping folks digitize their resources, helping with federal requirements, training for that to make sure all their documents are accessible, and also funding travel for conferences to bring DOT folks and other researchers and librarians together in the same room when oftentimes they don't get those opportunities to meet and talk with each other. This pooled fund is primarily library focused. So it used to be every state DOT had a research library. Not so much anymore. There's around 20-ish state DOT libraries left. And so a lot of the librarians, they're solo practitioners. They're kind of just in the trenches on their own, helping disseminate the state's research output. And in information management, we have a kind of a saying, record, store, ignore. You know, whenever an organization produces a research report, and I think we've seen a lot of great research already today, but what happens to those research reports? You know, it gets disseminated, bound, you have a copy of a report, and it gets shelved, it gets filed, and who knows who accesses that report and uses that information and that data. So as librarians in the field, we want to make sure everyone has access to that data. That data is disseminated, that research is used, and we're tracking who is using that data and information. And so that was one of the major goals of this project, to, again, help bring together all this research, all this literature, to make sure people do use it, and also to translate it into a usable format. So going forward, in this slide, I know it's a little hard to see, but on the left-hand side, there's a picture of the National Transportation Library. So this pooled fund was done in partnership with the US DOT and the National Transportation Library, who hosts all of the research materials produced from this pooled fund. So moving along. Clicker. Okay, again, I know that's a little hard to see, but the history of the pooled fund, it dates back to about 20 years ago, 2005. It was originally led by Wisconsin DOT with the goal of helping bring together transportation librarians and laying a foundation for communication and connectivity through the creation of an email listserv for transportation librarians, as well as a knowledge network that would help foster communities of practice, have monthly meetings, bring together information managers and specialists together in the same room to talk about current issues plaguing their DOTs. So again, we wanted to bring folks together, no one working in isolation. This pooled fund continued for 5 years and then was led by Missouri DOT from 2010 to 2015, that built upon this foundation of building groundwork for a communication network among the state DOTs and the transportation librarians in particular. And at this point, you may be asking, what does this have to do with me? Why are transportation librarians important to what I do? Well, we're going to get into that in just a second. Bear with me. Going back. So this iteration of the pooled fund, it's a continuation of the one started in 2005. It was spearheaded by ODOT around 2020. There was a 3-year gap when the pooled fund didn't exist due to some states that didn't want to lead the pooled fund, but thankfully, under the stewardship of Ron Kerb, ODOT stepped up and helped lead this pooled fund to great success, I think. So how this started out, in 2018, we sent out emails leveraging the network, the listserv that was created in the previous pooled fund, to talk to other state DOTs and say, who's interested in a new pooled fund? Who has needs? You know, what are your pain points? How do we help solve DOT research-related problems? And one of the main problems that they mentioned was, well, we need funding for resources, like resources libraries, we need funding for travel, and we also desperately need digitization support. We have so many reports, we have so many items, a lot of stuff that's pretty old, ancient by our standards, going back to the 1800s, that isn't digitized, that isn't accessible. So one of the goals of this new pooled fund was to make research more broadly accessible by helping with digitization. Other ideas were to help with federal training for Section 508. If anyone is a PI in the room, you may be familiar with Section 508. That has to do with making sure research reports are accessible by folks in the disabled community. You know, maybe you're colorblind, maybe you have certain vision issues where you can't see certain spectrums, certain colors, or just see, you know, at all, really. And so with that, with those federal requirements, we help train folks to make those reports accessible with folks with disabilities, like creating proper color contrast, creating alt text, descriptive text for images for folks who can't see those images. So those are some of the things this pooled fund was working on. And we have 18 states that are part of the pooled fund, and we've raised over $1.2 million. So you may be thinking, well, this sounds interesting, but holy cow, that's a lot of states and that's a lot of money for something. Why is this so important? Why did this gain such traction? And we really found there was such a need for digitization of resources and access to this literature. And one of the other things that we did was create a LibGuide. And if anyone's familiar with libraries, or maybe not familiar, a LibGuide is like a research knowledge base where it's bringing all the current best practices of research, all the current literature into one format. Think of it like a toolkit or a guidebook, or a SOP, if you will, of the state of information for that particular topic. So with this pooled fund, we created a lot of LibGuides for trending topics for transportation researchers and made them accessible online. So again, this digital focus, making more reports digitized, making them accessible, and also creating LibGuides that are digitized and online accessible as well. So one of the other items we created was a synthesis report on the future of transportation libraries. There's not a lot of us as there used to be, and so we're thinking, what do we need to do to remain agile and make sure we're relevant to DOT researchers or transportation researchers in general? And so this synthesis report, which is available on our pooled fund website, which I'll link to later, helps lay out the things that librarians need to do to make sure we're still relevant to everything that you do as practitioners. And again, that's helping leverage all the research, making it accessible and available, and making it findable. Because how many of you have been in a situation where you're starting a new topic and you have to do a literature search, you have to do a review, you have to find out what's been done? Well, these kinds of things help bring together all that information so it's at your hands instantly instead of you having to search on Google. You know, I don't know about you, but when I do a Google search and I get millions of results and it's like, that's a lot to comb through. Or through a pooled fund, you could have the librarians do it for you at a fraction of the time and the cost and have it instantly available to you on a website. So that was that synthesis report. Another thing we did was creating a toolkit of best practices for agencies without a transportation library. Again, there's not as many as there used to be, and a lot of state DOTs operate without an information or knowledge professional. And so what we did was create an online toolkit that shared how to archive material, how to catalog, how to make things accessible. Basically what we do as librarians, make it accessible to everyone so you know how to do that. If you are in charge of a research center or information manager, you have this toolkit at your fingertips to help make your research findable to all researchers. One of the other things we did, as I mentioned, was these resource guides. And think of it as a knowledge base, like we're creating and bringing together all the knowledge we can on a trending or current topic and putting it in an online format and making it accessible to you. So for example, we have LibGuides on hydrogen fuel cell technology, Internet of Things in transportation, and honestly, since this pooled fund is going, if you have a current topic, maybe you're researching bridge design or freeze thaw or any number of things, AI in transportation, let us know and we can do a literature search. We can create a resource or LibGuide and have all that information to you in a clickable, easily navigable resource posted online. Let us know, we can help. We're funded, we can do this kind of thing, and we're librarians, we know how to do that. So one of the other things is digitizing resources. Again, we've had materials sent to us, over 3,000 individual items sent from our 18 state DOT members that are cataloged in partnership with the Internet Archive. If any of you are familiar with that, what a wonderful resource the Internet Archive is. And they house all these materials that we've been able to digitize, newly available. This stuff was not available before we started this project. 3,000 items from all member state DOTs going back to the 1800s. So even if you're just a history buff and you want to see what things were like at a DOT in 1898, you can do that now through clickable links on the Internet Archive. We're always taking new materials, so if you have a stack of things that you want digitized, hit us up, let us know, and we'll see if we can fund that project for you. Also, Section 508 remediation I mentioned, again, this is making sure your research is accessible to folks who have disabilities. So we provided training resources and webinars and also created a template research report. That is, if you don't know anything about Section 508, you can access this template research report and it will guide you step by step how to make a research report accessible from scratch. So again, we brought all that information for you to be able to use. You don't even have to consult a professional. We have all this at your fingertips. So going along, lastly, one of the other things we did was support a virtual peer exchange. If some of you are with the DOT, you're familiar with what a peer exchange is. In this case, we brought together the research manager of South Dakota DOT with their counterparts in other state DOTs to trade inside best practices on how they manage their own research departments. So we have the capability to help fund these peer exchanges for organizations within the pooled fund who want to trade secrets, talk about how they do their research, et cetera. So we have some more pooled fund peer research projects in the future as well. So peer exchanges, so we're excited to have that continue in the next iteration of this pooled fund. So that's kind of what we've done in the pooled fund. The future of the pooled fund we feel is rather exciting. We're keeping some of our pillars, including digitization, Section 508 training, but we're also wanting to support a peer exchange among transportation librarians to help bring together folks from other state DOTs. Well, how do you maintain your library? How do you increase accessibility and findability and share that with members across the consortium? Other things that we want to do is create a LibGuide on what does every other state DOT have as far as research? What's unique about your state DOT's research holdings? And make that findable and searchable. Like maybe you're searching for a specific topic, but maybe Wisconsin DOT is an expert in that. We're gonna make sure you know that you know what each state DOT has in their holdings, what makes them special and unique, and ideally collate that and bring that information together in a findable research guide. So you can click on a state and find out, okay, what unique research is coming out of that state that's current and trending. One of the final pieces that we're excited to talk about is an AI chatbot. And I know sometimes if you hear AI, you may roll your eyes and be like, well, this is kind of a trending thing. How long is this gonna last? But with this topic, we've emphasized making it a closed and secure AI platform that is going to scan all of, at least for now, Oklahoma Department of Transportation's research and respond to queries about that research. Let me show you an example of that really quickly. I don't know if this comes through the screen very well. Let me go back. Okay, so AI chatbot, again, closed, secure AI service that's gonna answer your research questions. Maybe you're doing a bridge design, maybe you're doing some other design project, and you wanna know what are the current specifications or recommendations or best practices. Well, right now we have access to all of Oklahoma DOT's research, and you can type in a question in this platform, and it'll bring you answers based on what it knows from Oklahoma DOT's research reports. We want to expand this to as many members of the pooled fund as we can, like have access to Texas DOT, New York DOT, California DOT, as many as we can. So when you ask a question, it's going to give you a holistic response, scanning all of the historic research reports from when research reports started in that organization to the present. So it's going to be holistic. This is not available for consumer use yet. We're still in the testing phases. We're using Python coding for it, and we're hiring out a contractor for this project, and we're excited to see this go forward. So look forward to this. Right now, just ODOT reports, but hopefully other reports in the future that can help answer your research questions. So lastly, what does all this mean for you as practitioners? Well, a little bit of a summary. We've kind of built a foundational model. We've brought products for people to use in the form of LibGuides, in the form of chatbots, in the form of communication and networks and making research accessible. And we want to be innovative as we go towards the future, looking at new technologies and ways to disseminate and access information. Additionally, we're going to be digitizing more materials you can access, creating more synthesis reports for you to be able to understand the current trending topics, and just making research more available and findable. As librarians, that's what we're all about, information management, making things findable and accessible for you. Going back to the old adage, record, store, ignore, we want to move away from that. We want to make your research the first thing that pops up for people who are interested in that topic. So lastly, why go to the library? Well, for one thing, it saves time and money. Why pay an engineer's salary? I always like to say when you can pay a librarian's salary to do the same research for you and hopefully get back some quicker results. You don't need to be spending your valuable time trying to find stuff when you have information professionals who can do it for you. Also, we want to make sure that you're able to request literature searches. We're more accurate than Google. Again, you're going to find millions of hits when you do a search in Google, but we know exactly where to search with the other state DOTs to find the research that you need. And lastly, I will always want to plug our library. Visit the Oklahoma Transportation Library at oktl.org. We have a lot of resources, links to the pooled fund and results of this project. So many other things that I didn't have time to talk about. But again, as a librarian, our main goal is to make sure your research is findable for practitioners who need it, and also expand the scope of research and findability with new technologies and innovative ways of doing things. Everything I've said is online and accessible through LibGuides, through clickable links, and so PDF format. So we really don't have a lot of physical media related to this, but it's all online and freely available to you, whether you're a pooled fund member or not. If you want more information about anything I said, just hit me up at mmolina@ou.edu, and I appreciate your time. Thank you.
Thank you, Michael. You can stay for questions, yeah. Before we actually take questions from the audience, I'll ask the next speaker to come up so that we can start getting ready. But we have a few minutes to take questions from the audience, so any questions for Michael? I do have a question, actually. So the AI chatbot, that sounded very interesting. And I'm just wondering if you can tell us a little bit more about it. So is this going to be, is part of this going to be generative AI, or is this going to be just kind of combing through existing information? And if there is a generative component, what guardrails are they going to be so people have more confidence in those searches?
Excellent question. So there's going to be a generative component. It's going to be able to answer questions on the fly with language that's going to be put in by the workers who are on this project, the PI who's involved in this project. As far as guardrails and safety, again, it's going to be in a closed environment. It's not going to be connected to any other system that's going to be, you know, used for nefarious purposes. Like you type in a question, we're not going to sell that information to Google. You know, we're funded by public funds. We don't have a stake in trying to sell your information. So again, it's going to learn, it's going to grow, but it's not going to use that information for nefarious purposes. I know I say that and everyone thinks, well, AI, it's kind of, you know, it could automatically be nefarious anyway, but again, we're not going to be selling this information. We don't need to. We're already funded. We just want to make this a better product. So there's no reason to sell that. So, yeah.
Thank you. Any other questions? All right, well, thank you very much, Michael. I'd like to welcome our next speaker. You can be here on the podium, either way. The tip that I got is, as you work through the clicker, you should point over there. Otherwise, it wouldn't work. So our next speaker is Lance Underwood from Oklahoma Department of Transportation. He's the Enterprise System Services Director, and he's going to be talking to us about some artificial intelligence-driven solutions for transportation challenges. Thank you, Lance. Go ahead.
Thank you. All right. Well, thank you for joining me today. I'm going to talk about two different AI initiatives that we implemented at the Department of Transportation. A little bit of the context behind where we got started on this was originally the statewide strategy published by the governor a few years back, and we started looking at emerging technologies. So we had a couple use cases at the ODOT that were just something that we weren't going to throw human beings at the problem, essentially. So we partnered with OMES Data Services, and we tried to look at what were things that we could use within the current AI platforms to kind of solve a couple of these problems. So the two use cases I'm going to talk about, the first one is the Roadway Asset Inventory Image Recognition Initiative, and that's about reviewing roadway video to look for assets. And then the second one has to do with the right-of-way division's deed parcels. So they've got, you know, an entire state's history worth of deeds that we've begun to digitize, and we wanted to do some things with that data as well. So kind of looking at the first issue with the roadway images, it's a manual review problem. And so we have a staff within the GIS team that reviews roadway video that we collect every year. And the problem that we were running into is it was taking us about 2 years worth of human manual review just to get through 1 year worth of roadway images. And so we were just kind of digging ourselves a hole slowly. And we approached this with OMES Data Science. We initially looked at some vendors that were across the nation. We kind of got some idea about what the lift would be cost-wise. And AI is a little expensive right now, so we looked inward and worked with OMS Data Science, and the first phase was more about just looking at the feasibility of it all. We had the images, we knew we had the data, but could we do anything with it? And in that first phase, we were able to model the majority of the assets, and, oh, I jumped ahead. Go back one. So in the first phase, we looked at the assets, we kind of came up with a game plan and a statement of work on how we were going to tackle it, and we were able to produce some results. So we took a stretch of roadway, and we're at first just bare bones, can we even get anything out of the video? And we were able to do that. So we moved into a second phase, and this is where we kind of kicked it up a notch and really leveraged the Google Cloud platform and the AI processing within that. So they were able to teach the AI to look for the different assets, and this is everything from flagpoles to the striping on the ground. And the ultimate goal was to start working our way towards some of the more sophisticated components, the signals and lights, and eventually we'll be working on some additional priorities there too. So the end of the good story is that over this last summer, we did roll this out to production, and it hits every single highway road mile across Oklahoma. And that was about 52 terabytes of image data that we loaded into GCP and were able to process through. So those 3.5 years of images, we went from taking a manual review of the 2 years for one image, we got through an entire year's worth of images in less than 3 months. So it took a huge bite out of the manual lift to review those images. So the savings from the perspective of ODOT was that in that first year, if we had gone out and tried to use a vendor for this, it would have been pushing $500,000. So we were able to do this for essentially the cost of the folks that we worked with at OMES. And we saved an estimated 10,000 manual review hours by the folks that are reviewing that video, which is a huge, huge efficiency gain. And we were able to take those employees who would normally be reviewing that video and get them reassigned to other priorities, other things that we wanted to do within the department with those resources. So that was the first AI initiative that we tackled this last year. This next one had to do with our right-of-way deeds. And so this one is a little bit similar. We've got a lot of paper documents, about 250,000 documents in total that have parcel deed information across Oklahoma. But we have no data on this. It's just paper documents, right? And so that's not super helpful for the folks at ODOT. We have employees that would have to go into the filing cabinets if there was an open records request or even information that the right-of-way team wanted to know. Very manual effort. Go find it in the filing cabinet and then kind of pick through it to figure out what parcel that you're looking at. So it doesn't sound like that big of a deal, but here's an example of one of the parcel descriptions. Take a little bit of time for a human being to kind of pick through that, and I can tell you from looking at a few of these from 50, 60, 70 years ago, they're wildly different. Sometimes they're handwritten, sometimes they have references that are a little bit hard to follow. And so what we were able to do was train the AI to essentially read that for us and cut out about 83,000 hours worth of effort and cut it down. It was probably going to take us $6 million if we just wanted to have human beings go through and read every one of these parcels. It'd take about 20 minutes per parcel document if you were well trained and knew what you were doing. But the AI was able to read that in a much faster amount of time and give us an output, which is the parcel location, a traverse file that we can load into a GIS platform and then have a map of where this deed goes to. So we approached this a similar way. We had a couple different phases. We have a proof of concept, and now we're moving into the second phase. And from there, we're going to start leaning into, we're going to continue to use our partners at OMES Data Science to help us with this, but we've actually reached out to a vendor who has a solution called a Council of Agents. And so that's kind of the next step, I think, in the AI evolution of things, in which you have more than one AI engine, more than one AI attempt to process the data that you're looking at, and it helps increase the confidence level of the data that you're analyzing. So we're looking forward to implementing that here at the end of this year, and ultimately the goal is that that right-of-way team will have not only an easy way to see a visualization of where their deeds are or where their parcels are across the state through that GIS map. We'll also be able to do a little data mining into that data and in hopes build, we kind of mentioned it earlier, a natural language generative model to be able to ask questions of what's within that data set. So these are just two examples of the things that ODOT's starting to move forward on in the world of AI, and be happy to answer any questions you may have. Yes and no. So it is underway. Our content management team have begun scanning those deeds and uploading them into App Extender, and then we're going to get them moved over into GCP to be able to do the data processing part of it. But ultimately what the goal is to have first an internal tool for ODOT itself to be able to navigate that map of Oklahoma, zoom all the way down to the parcel location that you're looking for, and then pull up that deed, a scanned image of that deed, so you can take a look at it. So the next phase that we're looking at, we've got two different milestones. The first one's about 3 months out, and then the next one's about 3 or 4 months after that. So I'd say within the next 7 to 9 months, our goal is to have that site up and all of those deeds scanned in, all 250,000 images accessible through that site.
Might be loud enough for you to listen to me. Hi. So my question is related to the digital inventory. Okay, so once you create this inventory, what are you envisioning to do with this inventory? What is the potential application of it?
So yeah, that's a good question. So he's asking me what are we going to do with the asset inventory once we have it? So it's an effort that we already do that's manual. So the GIS team and other divisions at ODOT will look at those images, the roadway video essentially that we collect across the entire state. We do that every year. And normally there's a human that would sit and look at those and look for, okay, there's a damaged guardrail here, we've got a sign missing there. Those turn into work orders that eventually will correct those assets. But it's also part of the inventory management and count. So that's something that in the past that we've had to do manually, and now we'll have an automated way to do it that will give us a little bit quicker turnaround on knowing the status of each of our assets over time. So again, it's a practice that we've already got in place today. It's just AI is helping us speed up and catch up from that huge backlog that we have every year.
So the examples you gave, great examples, but could you give us some other examples where you see AI playing a great role in terms of automation, artificial intelligence to save cost and time?
Sure, yeah. So these two use case examples are just kind of the beginning point, some of the kind of the low-hanging fruit that we knew that we could point the technology at. But overall, we have a larger initiative at play to implement data governance across all of ODOT. And I think that is the foundation for any sort of data analysis like this, is you have to have a good data governance practice in place. And so that's part of what that we're putting in there. The other piece that we're doing as part of that is working with each of the individual business units, the divisions across ODOT, to kind of understand what are their data needs, what are things that they've had trouble getting an answer to in the past. Is it because the accessibility of the data? Does it have to do with the source of truth? Are they looking at the correct data set? Data governance is going to help us clear that up and answer those questions. But to specifically answer your question about where we're going next, natural language model AI and dashboarding using Google Cloud Platform and the the BigQuery Dataplex tool is where the data science team is really taking it next. So ultimately what my goal is within the next 1 to 2 years that I have enough natural language models built out of the data sets that we have at ODOT that leadership, executive management, folks really in the know will have an AI tool at their fingertips that they can go ask almost any question that they want to about the data sets that we have across the entire agency. So that includes bridge, construction, digital delivery. There's an assortment of high-profile production databases that we're pulling into GCP with the ultimate goal of building out these dashboards and natural language models.
I actually have one more question for you since we have a little bit of time. So with regards to the video processing generally, so image detection, identification has come a long way, but I'm wondering what's the amount of uncertainty or margin of error that you have and what kind of validation efforts have been underway to increase confidence in those results?
It's a good question. So initially when we did the first phase, when we were just doing proof of concepting, we were curious, as you are, is like how accurate is this going to be? Is it feasible to get through this much video? Those sorts of questions. In that proof of concept, I think the accuracy rate was a little above 91%. And as it's moved into those other phases, I think we've pushed that up past 95. And so it kind of depends on the asset. But where we stand now, we have an incredibly high confidence rate on the assets that the model's been able to identify so far.
That sounds great. So maybe a tougher question. What assets are the hardest to detect or like have the worst performance in seeing?
I think that was listed in one of my slides. I don't know if I can pull that one back up. We had that, maybe not. Oh, here we go. We had a step off the top of my head. Where did it go? Here we go. So I think anything that, obviously like the poles and some of the signal boxes, I think things that are smaller, we were having issues with, and then being able to identify the differences in the lanes and what direction it's going in. So I think some of those were the initial struggles, yeah.
Sounds good, thank you. Any other questions?
Providers, and you also mentioned about Google Cloud Services. Do you see any privacy issues that we are releasing our data to third-party data providers, if they are proprietary data and so on?
That's something that we looked at when we started down this road, and that's built into the agreements that we have with the vendors, that none of our data gets shared with third parties. It's our data. Really, the GCP is just a platform that we're doing our work inside of, and there's no risk beyond the just security permissions and being able to share that out. The typical thing that you run into when you have any closed system like that. But ours is ours is Oklahoma data. We're not sharing it with anybody else, and we've kind of looked at that as far as the agreements that we put in place before we move forward with any of the vendors. Yeah.
All right, thank you very much, Lance. I'd like to welcome our next speaker to the stage, Dr. Jamie Schussler, my colleague. She's an assistant professor at Oklahoma State University, and her presentation is on assessment of culvert conditions for transportation and hydraulic and aquatic connectivity. Thank you, Jamie.
Yeah, thank you so much, Maha. All right, well, good afternoon, everybody. I'd like to start my presentation, that's a long title, but by a show of hands, who knows what a culvert is? I'm gonna get you involved, all right. Who got here because a culvert was in place on your pathway today? Yeah. All right, who saw the culvert they used with their eyes? Oh. Okay, all right, some show of hands. And who has a really good definition of a culvert that they'd like to share? I was worried.
I'm a bridge engineer, so I would say it's not a span bridge that's less than 20 feet long, because more than 20 feet we consider it to be a bridge. So it could be a pipe or a concrete box.
Great. So we've got a definition in play here. So something less than 20 feet in span, could be a box, could be concrete, other materials. All right, I appreciate. Thanks for that definition. Okay. So I'm going to give you a definition that my team has come up with. Culverts are critical infrastructure for transportation, hydraulic, and aquatic connectivity. I think a lot of us as engineers forget that last piece, that aquatic connectivity piece. We say that these are commonly hidden with one or more barrels below an embankment, and they convey things like water, sediment, debris, aquatic and terrestrial organisms. Yes? Okay, we're gonna get there, thank you. All right, and so these are important to a lot of people in this state. They're important to people in this room, they're important to our transportation users, but we've got partners that these are also important to. People like Fish and Wildlife. Here we've got ODWC, or USGS, and the Conservation Commission. So we've got a lot of people who care about these structures that we wouldn't normally maybe think about in our engineering practice. So our research, the primary objective was to first locate culverts, and we're gonna get in this bridge culvert discussion. To locate them, identify culvert characteristics that lead to vulnerability, but we also want to identify these partners who we know care about culverts, who we can work with to retrofit some road stream crossings, and we can align not only our infrastructure goals, but also conservation goals. And so this project has been part of SPTC Cycle 1 and Cycle 2. Some of the strategic goals we felt like this hit was resilient infrastructure, resource allocation, and developing partnerships. We had a number of tasks, and I thought, this first task won't be so hard, a collection of culvert locations. But boy, this task was harder than I realized. Sorry? It's challenging. Yeah, creating a database, doing some site visits, developing a vulnerability framework, looking at different mitigation strategies that might work for us here in Oklahoma, and then some reporting. Now, I'm gonna be honest, we spent a lot more time in these two tasks than I ever thought we would. So, for my bridge engineers, I looked to you all, and that's right, if it's over 20 feet, it's considered a bridge. It might look like a culvert, might act like a culvert, but if it's over 20 feet, it's a bridge. But the best data that we had, or the best asset management we had of culverts, were bridges that were box culverts or similar. And when we started looking at the National Bridge Inventory, we saw it was close to half were on the DOT system, a little bit less, but more were off the DOT system. And then we started looking at the age of these culverts, and more than half are between 50 and 100 years old. Our culverts, or bridges, are getting older, and these are culverts. This is just looking at culverts, taking these out of the NBI. So we started, like I said, we relied on the data that we had. Thank you all who contribute to the NBI. And we looked specifically at culverts in fair to failed ratings, so 0 to 5 on a 9 scale. And we picked 104 of these sites in 22 different counties to visit. That is a lot of field work, and it takes a lot of folks to do it. And I want to give a special thanks to the team that made it happen. Tom Neeson at OU and Sarah Bondi, a student, and then several of my students at OSU. The first thing that we did when we were out on site was look, do the culverts out match the data that we have. And there's several highlights here where really the field measurements didn't actually line up with what we were seeing. But again, we weren't only looking for infrastructure parameters. We also wanted to look at culverts that might support conservation efforts and that aquatic and terrestrial connectivity as well. And so in addition to the different NIBI parameters, we also looked at the Southeast Aquatic Resources Partnership, which has a methodology to look at a road stream crossing to see if it is passable or impassable by fish. And so we looked at many different sites, which yes, I recognize some of these are going to be considered bridges, but we were looking at them for characteristics that might impede passability. Things like free falls, perched, so where your culvert is much above the water surface, and hard armoring. Some of these things we do because we're prioritizing the hydraulic piece or the transportation connectivity. But you could see why, if you were a fish swimming, these might be really hard to get through, and we have stream fragmentation. And of our 104 sites that we were looking at, 36% of them had a characteristic like this. Other things that make it very hard for a fish to pass: debris, sedimentation, blockages, skewed flow. And when we were looking at our sites, more than 50% had these characteristics. This is if you like more pie charts. It's the same data. Okay, now we were looking at any hydraulic structure and all of the possible road stream intersections in Oklahoma. There is a lot of road stream intersections in Oklahoma. Now, we determined this by overlaying both the hydrography and the transportation network. And we found that only 19% of hydraulic structures are represented on the NBI. So there's a lot out there that we don't know about. Thus, finding them is very challenging, and creating a comprehensive database is very, very challenging. Now, we're not the only people working on this. We've helped pull together some people on the aquatic connectivity team in Oklahoma. This has partners from the Conservation Commission, the OSU-OU, ODWC, Nature Conservancy, and US Fish and Wildlife. We had a 2-day road stream crossing inspection training where we were looking at these structures for both infrastructure and conservation priorities, in addition to just a meeting like this to try to get priorities aligned. Now, some of the goals of this team include a GIS inventory, creating a tool to prioritize structures where maybe we can work together. Maybe it's not just ODOT investing in these structures to retrofit and rehab. Maybe there is money available from US Fish and Wildlife to make something more passable. So how can we prioritize these and be talking the same language and developing state teams to help us figure this out? My research group alone is not big enough to comprehensively map all culverts, but now we've got a lot of players coming together for this. Now we have a aquatic connectivity barrier inventory and prioritization subgroup. We're active. There's a blitz next week if anybody wants to go out and look at these culverts with us. Happy to have you. But we're looking at priority watersheds to complete inventories. This is, where do we have species that are going to be impacted by stream fragmentation? And we want to prioritize those. We also want to identify funding sources and partners to bring to the table. Okay, so one of the things that we did was said, we're not going to get to every site, but how can we prioritize this? So we took the data that we had from the NBI and we cross-referenced with SARP. What are we collecting on both sides of the fence, per se, or both sides of the culvert? We have some of these parameters like culvert age, if it's available. We put that down, even in the SARP protocol. The width of the road, the culvert length, the ADT, if we can find it, the culvert height, the number of cells or barrels, culvert width, the number of lanes, culvert shape, and culvert material. And we used the data from NBI and evaluated several different machine learning methods and came up with how these features were most or least important. And we took this into a culvert prioritization tool, which is Excel-based, because a lot of our partners are much more comfortable using Excel. So we could take our findings from the machine learning method, put it into Excel, plug in some of these parameters, and figure out, do we need to go to this site, or is there a different site maybe we should prioritize? Pointing the wrong direction every time. Some other things that we are doing to try to improve and determine where these culverts are looking at different remote sensing methods. So using things like publicly available LiDAR, we don't even have to go to the site. Maybe we could just do a rapid remote assessment. There's some parameters that we can get, but we still miss a lot of the site context. And employing UAVs to be able to do some quicker visits and improving some of the safety of those visits. So our partners at OU, again, Dr. Tom Neeson, big thanks to him. They're working with some of the publicly available LiDAR data and seeing if this matches up with the data that we've collected in the field through this project and some others. And what we're seeing is that with structure length or more of those surface type measurements, we're getting really good agreements with the LiDAR data. But things like outlet drop, these more vertical measurements, these are really challenging with the LiDAR data. So we're starting now to explore with UAV photogrammetry and putting together these 3D models if we can fill in some of the gaps. We still need to go to the site and fly the site, but our site visits are much, much, much shorter. We can normally fly our culvert site in about 4 minutes. Now there's some more time for setup, but it's pretty quick. And so we can develop these 3D models, and then we are able to figure out some of the parameters for those inspections. Now what we're finding is we're getting a little bit closer with those vertical measurements, but we're still off. We've got really great agreement, again, with the structure length, but if we look at things like the inlet height, we're off between our ground measurements and our UAV. Now what we've been doing is using a fixed wing drone, and so it's taking these photos just straight down. Now we've partnered with a collaborator, Dr. Chen, who has a multi-rotor drone, and he is now able to look inside the structure as well. And so we're looking at connecting those photos to try to improve this vertical measurement accuracy. Some additional things, there's a lot of people in this room who've supported this research. Dan Cook said, hey, out by my house, there's a collapsed culvert. And I said, oh, we've got to go. And what we found was actually, it was the road around the culvert. And so if we just went and we did our ground inspection by foot, we'd see something like this photo, this ground view of the culvert. But when we look over top, we can get the whole picture here. We have debris blocking an inlet. We've got the culvert's intact, but our road has collapsed on top. So we're finding through this project there's additional applications as well. And Megan, my grad student now, is currently mapping a HUC 12 for all of the culverts, and we're comparing the LiDAR methods and the UAV survey data as well. And this is a subwatershed in the Little Blue River. So a couple of things here, some takeaways. Our smaller culverts are overlooked, they're hard to find, but we're trying to find some asset management strategies to be improved with these modern technology and available remote sensed data sets. And as our infrastructure is aging, we do have new design criteria and incentives for aquatic organism passage. So maybe we can consider mutual prioritization of the sites that we're looking at and the investment. I always think we're better together. And then while partners might have different priorities, there can be some crossover even when we don't expect it. We do have to learn to speak the language of our partners and have the harder conversations to align on these things. So that's it for my talk today, but I'd be happy. I love to talk culverts. My email's on the screen, but thank you so much, and I will pass it on to the next.
Thank you so much, Jamie. Do we have questions from the audience? I do have a question. So you talked a little bit about, the goal of this prioritization tool to find maybe the culverts where a retrofit is most needed. Can you speak to what a retrofit would mean in this case when you have different partners, perhaps with different priorities?
Yeah, absolutely. So I like to say what's good for aquatic connectivity is often good for hydraulic connectivity as well. And so we really like to see things, if you're not familiar, some strategies for aquatic organism passage is doing bottomless culverts or stream simulation through culverts. There's some looking at the different bed roughening throughout the culverts. So there's opportunities there, but the biggest thing is we don't want to have really steep slopes or super fast moving water. Now, right now, we are facing things like urbanization, and we're experiencing rainfall different than we ever have. So these structures that are 50, 100 years old, they could be designed for flows that we're experiencing much differently now. So high velocity flows, sizing of culverts is a really big thing. So there's a lot of conversations to be had around that piece.
Great. I have another question since we have a little bit more time. So I'm also really curious about what difference did you see when you went from having a drone that's just taking like a top image versus ones that can go a little bit more detailed? And what do you see is going to be the benefit in this kind of work that you're doing of these drones?
Yeah, absolutely. So when we are using our fixed wing drone and we're seeing just maybe in one direction straight down, it's hard to tell internal characteristics. Things like the number of cells we might be able to get, but really if there's any blockages within the culvert, this can be pretty challenging. It's hard sometimes to see the bottom of the culvert, especially if water is present. So there's several things like this, and when we've taken out a multi-rotor drone that has a gimbal that we can look inside the culverts and overlap these photos, we're able to see those internal structures and internal features a lot better. So the SARP protocol it's pretty detailed. It can take some time out on the site to do this. Now, if we're able to fly this post-process, then have things like machine learning and object detection fill in some of these characteristics, we can really improve the time that it takes. It's less people in the field, and also just safety in general. It's pretty nerve-wracking to send students out and just say, all right, get in the stream. One of my biggest complaints is how many snakes they saw that day. So.
Is it harder to operate, or the drones that go in and do more complex imaging?
I say yes. I'm pretty risk averse and pretty just conscious when flying UAV. So our fixed wing drone, it's very much like you set it and it goes, and what happens is happening. Now I've had Dr. Chen help me fly his multi-rotor, and maybe less risk averse than me, but can get quite close, and even says he'll go inside the culvert. So, yeah.
Any other questions from the audience?
I think
All
I get
right,
to
well,
pass it off.
thank you very much,
Yeah.
Jamie. I'd like to welcome our next speaker. I don't see him around. Oh, there he is. All right, my colleague, Dr. Mohammed Al-Kashif, Assistant Professor of Civil Environmental Engineering at Oklahoma State University. He is going to be talking to us today about the aging behavior of asphalt binders during the service life of pavements.
Okay, thanks, Ma, for the introduction. So first of all, I would like to thank you for sticking around. I wasn't expecting a large crowd at this time of the day. I assumed everyone will be gone after lunch. And one funny thing I noticed about the program is when I looked at the program, So the first presenter, technical presentation, was Dr. Tyler Concrete. So somehow they wanted to start with concrete and end with asphalt. So whoever put the program know that asphalt and concrete, they don't go together. So they wanted to make sure that there are so many presentations between us. So this project is, was funded by Oklahoma DOT. Okay, I'm not sure I'm doing this right. Oh, okay, I gotta face this. Okay, over there. Okay, good. So in this project, we're looking at aging, and just to get a sense of the room, so how many of you here know about asphalt, worked with asphalt? Okay, so David. Okay, so a few people. Kevin. So aging, just to give you an idea about what aging is, since this will be the core of the presentation. So with asphalt, one thing we struggle with is that asphalt ages with time. So just the nature of the material itself. So you get a piece of asphalt, leave it in the air, it's gonna oxidize and it's gonna change properties with time. So this is called aging. Has nothing to do with traffic, has nothing to do with the load applied on the pavement, just an inherent intrinsic property of the material. So asphalt ages during production. Asphalt also ages in service. So in this project, we're looking at what's called short-term aging. So we have short-term aging, which refers to aging during production, and then long-term aging is aging during the service life of the pavement. So here we're focused on the part of aging that happens during production, which we refer to as short-term aging. This slide shows the research team. So my students from OCU, Paul, who was the lead in this project, Mahdi, Hassan, David, ODOT. We've had a great input from David. He was very heavily involved in this. And then, of course, this would not have been possible without the support of ODOT, the ODOT Materials Office, Matt Romero, David, the people from the research office, Becky, Jerry, Gary. And we've had a lot of help from the industry during the sampling and collection of materials. So Evans and Associates, Overland Corporation, WSP, and Ingevity. We're all partners to this project. And we had multiple objectives. So one of the objectives, we're looking at cracking resistance of the plant mixes. The other objective was that we wanted to look at variability during production. And we also wanted to look at how we can simulate aging that happens during production using lab mixes. So we looked at different projects across the state. We had 6 projects that were selected for this study. These projects were located in different regions. We have different types of mixes, what's called S4 mixes and B4 mixes. These refer to, S here refers to what is called the super pave mix. B refer to what's called the BMD mix, so just 2 different ways of doing the mix design. And then for each mix, this table shows the version binder, the grade of the version binder. And by the way, if you're not, if you haven't worked with asphalt before, so asphalt, when I say asphalt, I'm talking about the asphalt mix. When I say binder, I'm talking the asphalt binder that holds the aggregate together. So the asphalt binder is that black sticky material that holds the aggregate together. And then the asphalt is just the entire mix. So here, this table, we had different mixes. In total, we had 6 mixes. Different version binders were used. Neat binders, polymer modified binders. We had also mixes that contained RAP. And RAP refers to what's called the reclaimed asphalt pavement. So it's just recycled asphalt that we use back in to make new asphalt. So it's just old asphalt that were milled from an old pavement, and then we're able to take this asphalt back and recycled it into a new mix. So we've had these different mixes that were sampled from different projects, and then for each mix, we went and collected samples from different lots. So a lot represents 1,000 ton of production. So depending on the size of the project, we decided to take one sample per lot, so that we're not just looking at the project, but also looking at lots within each of the project. So this table also shows the number of lots that we sampled from each particular project. So this is the overall plan. We started with mixed sampling. We had 3 projects in total. Those constituted 6 mixes, a total of 32 lots that we sampled. And then we had plant mixes, so mixes that we collected from the plant. And at the same time, we collected raw materials, and then we used those raw materials to make lab mixes. So this way, we're able to compare mixes that are produced in the plant versus mixes that are produced in the lab. And we subjected those mixes in the lab to do different aging conditions, so that we can see which aging condition simulates what happens in the lab. So we had this extensive plan laid ahead. And then for each of the plant mixes, we did testing that involved looking at the binder and looking at the mixture. Same thing for the lab mixes. We also did testing on the mixture and the binder. And then we combined all these results together so that at the end, we're able to, through a comparing between the plant mixes and lab mixes, we're able to select a short-term aging protocol that considers what happens in the plant. So as far as mixture testing, we used a very simple test called IDLCT. It's a cracking test. It's an indirect tensile test. So we have this specimen, cylindrical specimen. We subject it to a compressive force. This compressive force creates tensile stresses within the specimen, and it just breaks the specimen into 2. And then we take the load deformation curve, and then we do some analysis on the load deformation curve, and we come up with a parameter called CT index, which is essentially a measure of the cracking resistance of the mix. So this is a sample of the results. This is looking at 2 of the projects, 2 of the mixes. If you look at the results here, so the figure to the left is just one mix, looking at different lots. So looking at the results, you can tell the significant variability between the lots. So this is just one mix, and then you look at all these different boxes representing the same mix, and you look at the extent of variability. So there's clearly distinct differences in the cracking resistance depending on what lot you're sampling. So this can be very challenging when you're trying to put specifications based on this for acceptance in the plant. So if depends on which lot you're sampling, you could get completely different results. So this could be a challenge in terms of writing down specifications. It also raises the question of, if it's the same mix, how come we're getting totally different results depending on what lot we're sampling? So there must be something going on during production that induces this variability between the lots. And this is something that was true for all the mixes that we sampled. So depending on, regardless of what mix we're looking at, there is always this variability that was clearly observed between the lots of the same mix. So what we wanted to do is take these results and then compare this with the lab mix results. So we came up with this curve, which kind of combines everything together. This is a cumulative distribution curve. So the curve that you see in green, this represents the results from the plant mix. And you look at the curve and you can tell by looking at the curve the extent of the variability. So we had in total for this particular mix, I think we had about 30 samples. So some of the samples were giving us as low as 100 CT index, where other samples were giving us 250. So we took all the results and we plotted them as a cumulative distribution. And then we overlaid the results of the lab mixes. So what you see in red and gray, these are the results from the lab mixes for 2-hour and 4-hour aging. So of course, when we're doing lab mixes, we have better control over the mix. We have we're doing that in a controlled environment, so the variability is much less. So this is why when you look at variability of the 2-hour and 4-hour lab aging, it's much less compared to what we're seeing with the plant production. So we started looking at this, and then we were trying to figure out, so now that we have all this variability going on, whether the plant mix or also in the lab mixes, which one of these aging conditions better represent the plant conditions. So at first glance, if we just consider the average, the 2-hour STA seems to provide a better representation if we consider the average. However, if we consider the average, as, when we take the average, this means that 50% of our mixes would be below that average. So as far as quality control, this is not really something that we want to go with. So this is why we decided on looking at a different measure, which is called percent within limits. So the percent within limits, just to briefly explain what that means, if you look at this figure here, if I say percent within limits, 90%, so what I'm trying to say is I'm trying to pick the CT index, which would correspond to 90% of the mixes having a value that's greater than CT index. So this would align with a 10% on that cumulative probability curve. So at 10% on the cumulative probability curve, the CT index that corresponds to that 10% means 90% within limits, which means that 90% of the mixes above that limit, 90% of the mixes had a CT index that's higher than that limit. So we calculated the 90% within limits for each of the mixes. We compared that with the 2-hour and 4-hour aging, and we kind of reached the conclusion that even though the 2-hour on average better represents the mixes, but if we consider the variability and the extent of the variability, the 90% within limits would be a better measure, and in this case, the 4-hour aging would offer a better representation of the plant mixes. We also looked at aggregate gradation between lab mixes and plant mixes, and for the most part, plant mixes were finer, which was kind of expected. However, the differences was really within the production tolerance limits, so the differences were not as significant. Besides the mixture testing, we also wanted to look at the binder itself, so the asphalt binder. So we did different types of testing to look at high temperature binder properties, low temperature binder properties. We had this machine in our lab which does extraction recovery of the mix. So this basically works like a washing machine. So you would throw in the asphalt mix inside the machine, and then the machine would separate the asphalt binder from the aggregate. So this is a nice way to look at the binder properties if you have a plant mix and you're trying to test the binder from that plant mix. So we run it through the extraction recovery where we separate the asphalt binder from the mix and then take the asphalt binder and run it through binder testing. So this is an example of the results from the high temperature testing. So again, these results also align with what we found out from the cracking test as 4-hour aging seems to align better with plant aging. We also looked at the low temperature BBR properties. As far as the low temperature, the results were not that clear. So we had mixed trends, depends on the project and depends on the type of the mix. But then we took the low temperature BBR testing and the high temperature DSR testing, and we combined those to get the PG, the performance grade of the binder. And then we did that for the plant mixes as well as the lab mixes at 2 hours, the lab mixes at 4 hours. And again, if you look at the results here, so several things that we could deduce from this table. So the first thing is that when we compare the recovered binder with the virgin binder, so the recovered binder was stiffer, and this has to do with the RAB that was being added in some of the mixes, and also the different plant conditions compared to what we're doing in the lab. And the other thing that we noted is for the worm mix additives. So the worm mix additives use a special type of additive that helps reducing the temperature during production. So for these mixes in particular, and due to the effect of the worm mix additive on the mix, so the recovered binder in the lab was much less than the virgin binder, and this was attributed mainly to the effect of the worm mix additive. The last thing that we noted is, again, 4-hour aging, 4-hour STA aging, short-term aging seemed to align more with the plant mixes, and this was something that was also evident with the other tests that we did. So in summary, looking at all the testing that was done in this project, so the main thing is all the mixes, whether SuperPave or BMD, seem to satisfy the minimum CT index criteria that's proposed by Oklahoma DET, which is 100. So all the mixes on average gave us a minimum 100 CT index according to that specification. Significant variability was noted between the mixes, and this is something that will call for more investigation to try and get to the bottom of what's going on during production that leads to this type of variability. And as far as the short-term aging, 4-hour aging seems to offer a better simulation of the plant production as compared to the 2-hour aging. So with this, I would like to thank you again for your attention and welcome any questions.
Thank you, Mohammed. Any questions from the audience? Yeah, go ahead.
Hello, Professor. You talked about the both extracted binder properties as well as the. Sure, if you can go back to the table, the last table.
Can we show the slides again?
Can we get the slides back?
Yes.
This table here?
Yeah. So as part of the study, you tested both extracted binder from PMLC as well as LMLC, right?
Mm-hmm.
Did you extract the binder separately from RAP before even considering?
No, that's a good question, and it's a very good point. We did not do that. We plan to do that, so we plan to look at the RAP binder. But the RAP binder, I mean, the recovered binder, that includes in it the effect of the RAP. So if we were to test the RAP, and combine the wrap binder with the version binder, we would get the PG from the recovered binder.
I totally agree with you. I mean, that kind of.
Okay. No, but I mean, your point is very valid, and this is something we're working on. We're in the process of testing the wrap binder. It's an important piece of information, and we're planning to add that to the testing. Yeah.
Thank you.
Okay. Thank you.
Other questions? Yes.
So Mohammed, this is very interesting and important topic. Aging is a very hot topic, as you all know. Now, you looked at one of the aging, which is kind of limited, but how do you see, first of all, two or three part? One is you saw that high degree of variability. What do you do to reduce that? That's question number one. And question number two would be, some of these mixes that are produced even at different temperatures, you talked about partly warm mix and so on. So what would be the impact of, let's say, warm mix versus, even though we call it warm mix, but the temperature not necessarily is changed as much, right? So it may not be really warm.
Yeah.
So those two questions for now, and then last thing is that what does it mean relative to pavement performance? That's what we really care about, is what does it do to pavement performance, and how can you reduce the impact of aging with our better understanding so we have better performing pavement? I have probably too many questions.
Okay.
We answer whatever is doable.
Yeah, these are all good questions. I'm not sure if I'll be able to tackle all questions, but they're all valid and very important questions. So I guess the first question was, what is causing this aging, or how do we control this aging? Okay, how do we minimize the variability? Okay, so to answer that question, and this is something that we're working on with David now, is first, before we look at how to minimize the variability, we want to identify the sources of the variability. So is it something going on during production? I mean, is it maybe amount of RAB, aggregate binder content? Is it the type of the asphalt plant, the way that SRAB is being added? Could it be the sampling itself? So that may be something that has nothing to do with the mix, but it's just the way that we sample the material, the time that from the time at which we do the testing, from the point that we collect the sample. So how much time passes between the time we collect the sample and the time we do the testing, reheating, the effective reheating on the sample. So there could be too many things that would go into this, and to be able to better address how to reduce the variability is first we want to narrow down the causes of the variability and see which of these causes we can control through testing or through specifications. And then so we'll start with this, and then based on that, we'll be able to reduce the variability. And then we'll get to some variability which would be acceptable and which then could be accounted for in the specification in terms of like specifying tolerances for specifications. So that was for the first question, and I'm sorry, I forgot what the second question was. Oh, worm mix, yeah. So that's a very good point, and you're very correct regarding the fact that a lot of people use worm mix additives without actually producing worm mix temperatures. And for me, the way I define worm mix temperatures is mixes that are produced at reduce temperature. So if someone is using a warm mix additive and they're still producing the mix at hot mix temperature, it's not really a warm mix temperature. It's a hot mix asphalt. The warm mix additive could be there to help with compaction. Could also serve other purposes like anti-stripping, but it's not meant as a warm mix additive as such. And if I mean, I don't know, ODOT might have plans regarding if there is plans to expand warm mix additive, then whether controlling the temperature during production, whether that's something that they might consider doing, just to enforce that warm mixes are actually produced at warm mix temperatures. And then there was one more question. Okay.
All right,
Thank
so we are 2 minutes behind now, so in the interest of time, I will close the session. I would like to thank all of our speakers again. Let's give them another round of applause. Thank you again for attending this session, and feel free to find the speakers and ask them more questions if you have more questions. Thank you. I think there is now network